The title of this is called Ratio and Proportion Part 1, and we're going to cover Standard 5. We're actually preparing for Standard 5 during this lesson. And we have two objectives for this lesson. First, you're going to be able to write and simplify ratios. And second, you're going to be able to use ratios and proportions to solve problems. All right? So let's go ahead and take a look at what a ratio is. So a ratio compares two numbers by division. Okay? And you can see here that basically we have three ways that we can write a ratio. Okay, we have 2, 2, 3, which is comparing, for example, if in a room there's 3 people and 2 of those are females and 1 is a guy, you can say the ratio of females to the total people in the room would be 2 to 3. Okay, and you can also write a ratio as 2 over 3 or 2 colon 3. Each one of these three mean exactly the same thing. There's just 3 different ways to write it. Okay. Generally, though, you're going to see this 2 over 3 here is going to be the standard form that we're really going to use when we deal with ratios and proportions. All right. So, how do we express ratios in simplified form? Okay, and usually whenever we express ratios, we always express it in a simplified form. So you can see here that a ratio of 4 to 8 would reduce down and become 1 to 2 because 4 goes into 4 once and 4 goes into 8 twice. Okay, so you would reduce it like you would a regular standard fraction. Okay, here 2 colon 6 becomes 1 colon 3 because 2 goes into 2 once and 2 goes into 6 3 times. Here you have 15 over 20, which reduces down to 3 over 4 because 5 goes into 15 3 times and 5 goes into 20 4 times. All right. So let's look at how we can actually simplify ratios when we're given units of measure that go along with it. All right. And you can see here that for our first problem, we're given 12 centimeters divided by 4 meters. Well, we can't really reduce this down right now because our numerator's in centimeters and our denominator's in meters. And before we can reduce or simplify, we need to get a common unit of measure. So generally the rule that you're going to use is you're going to always break down the largest unit of measure. Okay, so centimeters we know are little itty bitty units of measure. Okay, smaller than an inch. Okay, actually smaller than probably about a quarter of an inch, whereas a meter is more like 3 feet. Okay, so we're going to want to break this 4 meters down into centimeters. Okay, so if you look in the back of your book, you're going to see a chart that's called Table of Measures. Okay, and this is going to be where you're going to pull all your measurements off of, and in there you're going to see 1 meter equals 100 centimeters. Okay, and basically all we're doing is we're going to take this 4 meters and we're going to rewrite this so that way we can break it down into centimeters. So the 12 centimeters is going to stay on top. We're just going to multiply this 4 meters here by 100 centimeters because for every meter it's 100 centimeters. So then we end up with 12 centimeters over 4 times 100, which is 400 centimeters. And now we can get rid of our unit of measure because we don't need that now since they're in the same exact unit. So we get 12 over 400, and 12 goes into 12 over 400 reduces down to 3 over 100. 4 goes into 12 3 times, and 4 goes into 400 100 times. And we would have our answer here. Okay? So now let's go ahead and take a look at our second example here. And here we have 6 feet over 18 inches. Okay? Now, 6 feet is obviously bigger than, or feet is obviously bigger than inches. And we know that 1 foot equals 12 inches. So we want to break down our largest unit of measure, which is feet. So if we're going to take 6 and multiply it by 12 inches per foot. And our 18 inches is going to stay the same. So when we do that, we end up with 6 times 12, which gives us 72 inches over 18 inches. And then we can get rid of our unit of measure now, since we have the same exact thing, since they're both in inches. And 72 over 18 reduces to 4 over 1. Okay? And because we're dealing with ratios, we want to keep it in this form here, in this fraction form or ratio form. Okay? And this would be how we would simplify units of measure for ratios. Now remember, we always break down the largest unit of measure. Okay, that's going to be the rule, the standard rule that we use during this. All right. So let's go ahead and take a look at how we can use ratios to actually find lengths of a figure. All right. So here we're given a rectangle, and we don't know what the length is, and we don't know what the width is. Okay. But let's see what we're actually given here. So our problem says find the length and width if the perimeter is 60 centimeters and the ratio of AB to BC is 3 to 2. So basically length is AB and width is BC. So we want a length to width ratio. Okay. Because our ratio is 3 to 2, okay, we're basically what we're going to do is we would redraw our rectangle. And for my length, because you can see here, here's AB to BC, and our ratio is 3 to 2. So these two, AB and 3, correspond to each other. Okay? So where my length is, I'm going to put, see here's AB, C, D. Where my length is, AB, I'm going to put 3x. And because it's a rectangle, my opposite side here is going to be 3x. And then BC is 2. So I'm going to make BC 2x, and my opposite side here 2x. Okay? And because we're dealing with perimeter, what we want to do now is we want to add the length of all 4 sides of our rectangle and set it equal to our perimeter. So we're going to take 3x plus 2x plus 3x plus 2x, and we're going to set that equal to 60 centimeters, because that's our perimeter. And when we add all of our x's up here, we end up with 10x equals 60 centimeters. We divide both sides by 10. And our 10's cancel out, leaving us with x equals 6 centimeters. Okay. And right now we're not done. Okay, we just solved for x. So now what we want to do is, in order to find our length, which is AB, we're going to substitute that into our formula here. So if AB equals 3x, and I know x is 6, I'm going to substitute 6 in for x, so then AB equals 3 times 6. So I know AB equals 18. So there's my length. Now I want to find my width. So for my width, I know that BC equals 2x. And since x is 6, I'm going to substitute that in. So BC equals 2 times 6. So BC equals 12. Okay, and both of these are in centimeters. So we have the solution for our length and our width using ratios. All right. So let's go ahead and take a look at what's called an extended ratio. Excuse me. So for this, we're given a triangle, JLK, or JKL, however you want to say it. And we want to find the measure of each angle if the ratios are 1 to 2 to 3. Okay. So, looking at this triangle here, you can see that angle J is going to be the smallest angle, and angle L is going to be the largest angle. Okay. So basically what we want to do is we want to do the same thing that we just did on the other one. We want to take our ratio and substitute those in for our angles. Okay, since J is our smallest angle, it's going to get the smallest number in our ratio here. Okay, so I'm going to redraw my triangle here. Okay, and here's J, here's L, here's K. So what I want to do is I want to make angle J, since it's my smallest angle, I'm going to use the 1 in my ratio since that's the smallest number in my ratio. And I'm going to make this one 1x. Okay? Now, since K is the second largest, or actually, let's go ahead and do this. If L is the largest angle in my triangle, then I want to use the largest number in the ratio for that. So I'm going to make angle L 3x, which means that we just use the 1 and the 3, and it leaves us with 2. So which means that angle K is going to be 2x. Now in order to find x and solve for x, we're going to add all three of these angles together. So we have x plus 2x plus 3x. And I want to set those equal to 180 degrees, because we know that there's 180 degrees inside of a triangle if we add up all three of the angles. So now we add all of our x's up here, and we get 6x equals 180 degrees. We divide both sides by 6. That cancels our 6's out here, leaving us with x equals 30 degrees. Okay. So we solve for x, but now we got to take x and we got to plug it back into each one of our angles. Okay. So if angle J equals x, and I know that x is 30, that means that angle J equals 30 degrees. Okay. So there's angle J. So then I want to do the same thing for angle K and L. So then if angle K equals 2x, and I know x is 30, I want to substitute 30 in for x. So I get angle K equals 2 times 30. So angle K equals 60 degrees. So now we know what angle K is. And then now we need to find angle L. So we know angle L equals 3x. And if x is 30 degrees, I'm going to substitute that in for x. So angle L equals 3 times 30, which means that angle L equals 90 degrees. Okay? And we have the measure of our three angles, angle J, angle K, and angle L. All right? Now let's go ahead and take a look at another aspect of ratios, and that's called proportions. And a proportion is basically an equation stating that two ratios are equal. And you can see here that I have a ratio of 2/3 equal to a ratio of 8/12. So we have two ratios equal to each other. Okay. Now, the first thing that you need to know here, and all you have to be able to do is to identify these terms. The 8 and the 3 are what we call our means. Okay, and the 2 and the 12 are what we call the extremes. Okay, and right now you're just going to be asked to recall these two and be able to identify which terms are the means and which ones are the extremes. Okay, so let's go ahead and take a look here at 3 over 4 equals 9 over 2. Okay, and we can see here why a proportion is an equation stating that two ratios are equal. So 3 over 4 is already reduced down. So let's go ahead and reduce 9 over 12 down. And when we do that, we get 3 over 4 equals 3 goes into 9 3 times, and 3 goes into 12 4 times. So you can see that 3/4 equals 3/4. Okay, that's why it's referred to as a proportion, and we set them equal to each other. All right. So let's go ahead and take a look at how we can actually solve a proportion, though. So I'm going to use a proportion that we already have the numbers here, just so it makes it a little easier so you can see how cross-product property works. And basically, cross-product property states that if we multiply the product of each diagonal together, we can set it equal to the other diagonal. So for instance, 4 over 8 equals 5 over 10. We're going to multiply our first diagonal, which is 4 times 10. So 4 times 10, and we can set it equal to our other diagonal, which is 8 times 5, or 5 times 8, either way. Okay, so let's go ahead and simplify this out and see if this product actually works. So 4 times 10 would give us 40. 5 times 8 gives us 40. Okay, so you can see here that 40 does equal 40. Okay, so you can see here how cross-product property actually works and that it does work. All right. So let's go ahead and take a look at our first problem at this time. All right. And our first problem is going to be 5 over x equals 45 over 63. Okay. And we have our proportion. We have one ratio equal to another. And we are going to use cross-product property. So the first thing we want to do is we want to cross multiply. So we get 5 times 63, and we're going to set it to our other cross product. X times 45, which gives us 45x. All right. Now, all we want to do here is we just want to simplify. So 5 times 63 gives us 315 equals 45x. In order to get rid of this 45 here, I have to divide both sides by 45. When I do that, those 45s cancel out. And I'm left with x equals 315 divided by 45, which is 7. And we have the solution to our proportion. All right, so let's go ahead and take a look at another example here. Right, now this example is a little bit more difficult just because instead of having one variable, we have two. Okay, but they are the same variable, which does simplify our life a lot. Okay, so for this problem, we have 3 over y plus 2 equals 2 over y. And we want to use cross-product property to solve this. So we take our first cross product, 3 times y, and we write it down. So 3y, and we set it equal to our other cross product, which is 2 times y plus 2. So we end up writing 2 parentheses y plus 2 close parentheses. Now the reason that y plus 2 is in parentheses is because we're not just multiplying 2 times y. We're multiplying 2 times y plus 2. So we're multiplying it by this whole thing. Okay? And because this is a binomial, meaning that there's more than one number or term, we got to place it in parentheses. Okay? So now we want to just simplify. So we end up with 3y equals, and we have to take this 2 and distribute it to the y and the 2 as well. Okay? So 2 times y gives us 2y. 2 times positive 2 gives us a positive 4. And we want to solve for y. So we subtract 2y from each side. That cancels our y's out here. And it leaves us with a y on this side and a positive 4 on this side. And we have our solution, y equals 4. All right. That concludes this lesson on ratios and proportions part 1. If you have any questions, go ahead and raise your hand and ask for assistance. If not, congratulations, and go ahead and get started on the worksheet and have fun.